after lunch. But let's begin. So we already learned about the slope. Now we're going to talk about the equation of the line. I want you to know that the equation of the line is called slope-intercept form. That is what the equation of the line, the first version. We're going to learn two versions in grade 9, but the first version, the equation of a line in slope-intercept form, is called y is equal to mx plus b, where my slope is the m and my b represents the y-intercept. I'm going to give you some time to copy this table, and I'm actually defining the slope here. The slope is the steepness of the line. We also refer to this as the rate of change. We're talking about the rate of change in the last class. And the y-intercept represents the point where the graph crosses the y-axis. So you know when the graph crosses the y-axis, my x coordinates of the point are all 0, but my y coordinates of the point are going to be my b term, -5, +2, +8, 0 in this case when we don't have a b. And we're going to talk about the last one in a little bit. My slope, my m, my slope is always the term in front of my x. So here I have -2, +1, 2/5, -1/2. That is my slope. If everyone can take a minute and copy that down, please.
Okay, so when we're analyzing for vertical asymptotes, we learned this yesterday that when we restrict anything in the denominator, that results in vertical asymptote.
So we have the steepness of the line is my slope. The point where the graph crosses the y-axis is my y-intercept. Now for this question over here, y is equal to 4. Do I have a slope? Do I have an mx?
Not a vertical asymptote.
No, I do not have a mx. So in that case, my slope is equal to 0 because it kind of doesn't exist. And I only have a y-intercept because I have a horizontal line. Okay, so make special note of the horizontal line.
So how is there? Oh, sorry, not to them specifically, just make a general announcement.
Or just
Okay, let me just make sure.
what this is saying is, let's say we common factor. I common factor this.
Okay, can I switch to the next slide, kids?
Common factor.
Give you a second to draw or sketch this graph. And just write the question out with special attention to my slope formula. I'll give you a second to copy this out. So this slope formula that hopefully the supply teacher practiced with you, y2 minus y1 over x2 minus x1.
Where you cancel this up with the opposite. So usually I'm going to do a quick sketch, not what this looks like. Yeah. When graph has a hole, graph it like this. So go on to Desmond and ever plot a function. The function is undefined. That all say it's on or that it's connected. So it's all connected because there's a hole at that particular value. Leave that one up. Let's see what happens when graph it up then.
Oh, I see. Yeah, right. But why would it?
Okay, so it's a straight line because when we factored it out, we ended up getting y equals 2 over 3. The horizontal line. However, it's not just a horizontal line at 2 over 3, which is 0.666. But when we go to 2, see how there's a hole there? That means it's undefined. Okay, so anytime we have common factors that get canceled out, those actually are holes in the function. Now notice though, it's not a -2. Okay, so it's always the opposite sign. And again, we figured that out algebraically by setting it to 0 and rearranging it, but it's always the opposite sign. So it's undefined at +2. Okay, and then sometimes you might get functions that have multiple factors. Okay, so you might have multiple factors, might not be a horizontal line, but the key takeaway from this is anytime you cancel something out, that they have common factors in the numerator and the denominator, that results in a hole when you graph the function. So that's what part B is saying. So in an x, if an x value is a 0 in the numerator and denominator, this results in a hole in the graph, not a vertical asymptote. Okay, so if you notice, there was no vertical asymptote at x equals 2. It was just a hole in the graph. Okay, so there, for the third one there is a horizontal asymptote at the ratio of the leading coefficients, which gives us the equation of y equals a over c. Okay.
This is the one.
The other one, just for her.
Someone who.
Sorry,
Oh. Okay. So just,
Okay, so over here, how am I getting these 2 points? Can someone tell me? Erica?
Point is the one on the line.
Yes.
Okay, so my coefficients.
Perfect. Yes, thank you. So we only need 2 points on the graph to figure out the slope. I picked 2 random points. The first point I picked is actually also the y-intercept. And the second point was just a random point. So the leftmost point, we always want to make the leftmost point 0, -5 is our x1, y1. 3, -3, x2, y2.
So all I did was make up an equation.
So our slope formula, slope is equal to +2 over 3. Once we plug in -3 minus -5, 3 minus 0, we get our slope formula.
That there's a vertical asymptote along,
And we calculate that the slope is 2/3. That makes sense because I have to go up by 2, rise of 2, +2, and then 1, 2, 3, right by 3. So my rise is 2, my run is 3. So that makes complete sense. And once you have the slope and the y-intercept, we can simply put the equation y is equal to mx plus b to be in slope-intercept form.
For any functions, you can set y equals to 0, and like any other function, if you want to find the y-intercept, you let x. Okay, so let's look at an example of the remaining properties. If you can get through with that. So we're going to graph this function. So the function is x minus 3, x plus 2.
So
Okay,
often
graph
in your
is
unit
something
guide,
we're
you're
going
either going to be asked to find the
analyze
slope
the different
or
features.
the y-intercept.
So they're already in simplified form, so there's no common factors to cancel out. So that indicates that there's no hole in my function. That's one thing we can start with. Then the denominator is going to tell me where my vertical asymptote is going to be. Okay, because that's the restriction. Okay, so my vertical
Let's move to
asymptote
the
is
next
outside
question. I believe it also has another graph.
at x
So
equals
this time my y-intercept was 0, 3. This is my leftmost point. So that's why I've called it x1, y1.
Yeah, I'll just show you the
My
graph.
second point,
So this would be
1, 1, I've labeled that as x2, y2.
draw your vertical
So we
asymptote.
always
Your
go
vertical asymptote.
from left to right. Now,
The
we
horizontal
talked
asymptote,
about
always
this in
equal to
terms of
8 over
social media graphs.
okay?
Would this
So
be
horizontal
increase
asymptote
in
is
followers
equal
on
to
social media? Or am I
So
losing
this is
followers, a
equal to
decrease
our
in
line.
followers? Everyone's hand should be up.
our
Lauren?
horizontal asymptote is gonna be
Yes,
at
we're
y2.
losing. We're losing followers on social media. So if I'm losing, I'm going to expect when I do my slope calculation for this to be a negative number. That would represent losing something. So I have 1 minus 3, y2 minus y1, 1 minus 3 over x2 minus x1.
Now you have your
So 1 minus 3 minus and 1 minus 0. That gives me negative 2 over 1, which is a slope of negative 2. That makes sense. We're losing followers. This is a decline. So I have a negative slope. And remember, I already know that from the graph, my y-intercept is 0, 3. So, did I not write this? Okay. So I know my slope now, negative 2. My b value, positive 3. So my equation of the line would be y is equal to negative 2 x positive 3.
When I want to determine my
Negative 2x plus 3, equation of the line. You're noticing we have far less steps than what you are, the test you're studying for tomorrow. Far less steps. However, as we get to next week's lesson, the difficulty will increase. And we are going to have to use some distributive property and other concepts later on.
So if you want to determine another pair, because you want to try to sketch your graph as accurately as possible, you can plug in another value for f of x, or for x. So you can determine f of negative. In this case, we're doing f of negative 1.5. So if you plug in f of negative 1.5.
When we have a horizontal line, we still have to, you notice that all of the y coordinates are the same for my horizontal line. But when I'm using my slope, I still have to make special note that my x1, y1 is my leftmost point. That is also my y-intercept. So I have x1, y1, x2, y2. I'm plugging this into my slope formula. So y2 minus y1, 4 minus 4, over 1 minus 0. Now my answer, 4 minus 4 is 0. What is 0 divided by 1 equal to? Josh, what is 0 divided by 1? 0, good. And that matches with what we learned last time, that all horizontal slopes have, all horizontal lines, sorry, have a slope of 0. So in this case, my slope is 0, my y-intercept is +4. So the equation of the line is y is equal to 4. That's the equation of the line.
This distance here and this distance here have to be the same. So how do we sketch this part of the function? We're going to kind of base it off of these points here. Okay? And then just underneath there, it says, once you know the shape of one branch, you can translate the points to the graph of the other branch. So what I'm going to put a decimal spot that way you can see the coordinates a little bit more.
Okay, I'll give you a second to copy this problem, and I'm going to explain it in 1 second. So we dealt with horizontal lines. Now we're going to deal with vertical lines.
So I'm also going to plot in my asymptotes, which is that the horizontal one at y=1, and then have the vertical one at y equals. Okay, so the coordinate that we plotted on our graph was the x-intercept.
Okay, so this time,
And negative.
what I wanted to ask you, do we have a leftmost point? No. Both points are on the x coordinate is equal to 2. So it really doesn't matter which one you label your x1 and which one you label your y1 as, I'm sorry, x2, y2 and x1, y1, as long as you're plugging the right values into your formula. Y2 minus y1 over x2 minus x1 gives me 2 minus 0 over 2 minus 2. Now, the number one mistake I see on a question like this is students think that 2 over 0 is equal to 0. It is not. When there's a 0 in the denominator, you can even check by plugging it into a calculator. 2 divided by 0 is not 0. You'll get an error on your calculator. And that's why we say that the slope of vertical lines are undefined. And we also have no y-intercept often when we have vertical lines. So I have no y-intercept. I don't have a slope. So I can't just say nothing for the equation. So I have to look at my x-intercept. The graph intersects the x-axis when x is equal to 2. That's where the graph intersects the x-axis. So that is going to be the equation of a line. All vertical lines have their equation according to their x-intercept, not their y-intercept, but their x-intercept, because there is no slope and there is no y-intercept.
Okay, so let me just label that and I'll say that again. Okay, so what I did was started here and I almost created. Okay, so everyone at home. So I'm almost creating like a max here for myself. So I went down 1 and I went over 5. That's where I got this point here. So now I want to do the opposite. So I'm going to go up 1, over 5. So 1, 2, 4, 5. That takes me to 6. And I get to do 1. So that helps me now to show distance marks for the hyperbola. So now I have this point here and this point
Okay,
here.
so this is what I want you to copy into your notes. All horizontal lines have a slope of 0 and an equation of the form y is equal to b, where b is the y-intercept. All vertical lines have an undefined slope, an equation of the form x is equal to a, where a is the x-intercept. That's what you'll see in your textbook. And that's what you
No, it's
want
on,
in your notes, please.
It's on Desmos, but maybe you can't see me writing. So I'll use the arrow. You see the writing that I wrote out on there? Okay, so you can't see it. Okay, so it's working in class, but you can't see it online. So what I did was I went down 1 and I went over 5. So to map this coordinate on the other curve, I'm going to do the opposite. I'm going to go up 5 and over, sorry, up 1 and over 5 to map it here. Okay? And you would do the same thing with these ones. You're almost counting to create the equal distance portion of the, or to apply the equal distance portion property so that you can sketch this part of the curve as well. Okay? No, I'm just talking. Yeah. So you should see Desmos, and now I'm going to go back to Marker. Okay, so now it's on. Any questions about that?
So even if you
So
want to
once
leave
you
some
sketch
space, this is in the notes that I have posted. I'll let you give you some more time. I just want to see what's next.
Okay, so you're using the point on one side to map the points on the other. Okay, so let me see if I can do it. Yeah, let me see if I can do it on this. So the points are equal distance from the point of intersection of the two axes. So I'll do it here again. So let's start with this coordinate here, which is 2 and 0. So from this point, I go down 1, and then I go across, and if there's a count, it's 5. So I go down 1 and to the right 5.
Okay.
it's
So
five.
the next example you don't have to copy down, but we can apply this to the real world. So for example, it says Tracy is obviously walking. She's starting at 5 meters away, and it takes her 10 seconds to get to her destination. So we can calculate the speed that Tracy is walking using the slope, because the slope represents the steepness of the line. It can also represent distance over time, which is equal to speed. So it's just an example how we can use the slope to describe that she is moving the distance. She's starting away from the sensor and she's moving towards the sensor. So this is just a real, in the academic course last year, we had a lot of word problems. Okay, so now I wanted to focus, because I didn't get to teach this concept with you when you had a supply teacher. We want to talk about when we know the slope and when we know the y-intercept, how we can graph these lines. So a slope, the equation y is equal to 2/3 x plus 1. I can have a slope of 2/3 and y-intercept of 1. What that means is if we are moving to the right of whatever our starting point is, any point that is our starting point, usually we start with the y-intercept, but if we're moving to the right of the starting point, then our rise is going to be +2 and our run is going to be +3. However, if we are moving to the left of the starting point, we have to do the opposite. Our rise would be -2, our run would be -3. This is only when we're graphing our lines. So if you can take a picture of this and include in your notes, just so that you know to do our calculations, we have to always think of the rise and run differently from the left of our starting point and to the right of our starting point.
First thing you can look at is this one, I think. If you look at where the vertical asymptote is, you look at state the restriction in the denominator. You look at the denominator. So the restriction there is that x cannot equal 1, which indicates that our
Okay,
vertical
so
asymptote
what does that
is
look
at
like?
x
If I
equals
start at this y-intercept
in this case,
starting
we're showing
point,
the
then
steps
if
for
I'm
how
going
steps
to the
are
right,
taken.
I'm going positive
So
2
x equals 1,
positive
let's start with that.
3
So I'm gonna put my grid.
each time. However, if I'm going to the left of the starting point, I'm going to go down by 2, down by 3. So -2, -3.
Okay, so here's my vertical asymptote.
So the
at
right and the left look different. Don't have to copy this in your notes, but it is there in my notes if you would like to see. Now we can also calculate rise and run using algebra, which I'm going to get to in a second.
A over C.
Graph the line -3x minus 5 using the slope and the y-intercept. So if my slope is -3 over 1, -3, that actually means my rise is -3, my run is +1. So when I'm starting from my starting point being the y-intercept, well, then I'm going to go from my y-intercept -3, -3, +1. Down by 3, right by 1. But if I want to get more points to the left of my starting point, I have to do the opposite. Left by 1, up by 3. Left by 1, up by 3. Left by 1, up by 3. So when you're graphing your lines, it can be a little complicated if you don't remember that the slope is going to be the different to the left and to the right. Now, on your test this year, I am not going to include any graphing. I will have drawn the graphs for you, and you have to identify the right slope and y-intercept. But next year, when you're in grade 10, you are going to have to graph these things.
So let's take a look at that, and then we're going to go to our graph. And we're gonna
Okay. Now, what if you are given just 2 points on the line? So if I have points -5, +3, and 8, 3, what is the y-intercept? Well, if we actually plug these points in on a line, I will find that I have a horizontal line here. So I have my leftmost point, -8, +3, and I have my rightmost point. My y-intercept is this value when x is equal to, when x is equal to 0, y is equal to 3. So my slope is equal to 3. And because we have a horizontal line, my slope for this question is equal to 0. Okay, so when I'm plugging this into the equation, remember it's y is equal to m times x. So if my slope is equal to 0, 0 times x is equal to 0. This completely disappears. All I'm left with is my b, which is my y-intercept. So all horizontal lines have the coordinate of their y-intercept, the b in this case. Okay, just for your own knowledge, but we've already dealt with horizontal lines.
So some other
With vertical lines,
are
you don't even have to plug in your x1, y1, x2, y2. Right away, when you have a vertical line, you know that there is no y-intercept. You also know that the slope is undefined. So all that you really want is the x-intercept. X is equal to 5, and that is the equation of the line.
So I'm going to plot 2 and 1 and 3 and 1.5.
Because x is equal to 5. All vertical lines we know have the x-intercept as the equation of the line. Okay, So these are just tips and tricks to help with your homework this week. The last thing I want you to include in your notes before tomorrow's lesson is the bottom. When you are required to graph a line using the slope and the y-intercept, I want to see these 3 points. We want to plot the y-intercept. We want to use the slope to plot other points on the line. And we want to draw a straight line through the points you have plotted. Okay, let me stop sharing for 1 second. I'm going to stop